Alright, hey, what's up everybody? This is Papa Bale. Welcome to the channel. I wanted to do this live stream to just kind of get it out in the open exactly what this is. Okay, this is not a free energy machine. Okay, this is not a perpetual motion device. Somehow it being a pulse motor linked it all to all that stuff. But it's not, it doesn't do that. Alright, so mechanics of the whole thing. We got a power supply. And it's connected with the positive and the negative. The positive goes to these switches. Goes to a couple places. It goes to the switches, which will feed the electricity into each individual strand. And then from there, this is just the mechanics of the whole thing. I'll get into some funner stuff in a little bit. We numbered each strand, and then one goes to one all the way around until it hits the transistors. 1, 2, 3, 4, 5, 6. And then there's a base pin, a collector pin, and an emitter pin for each transistor. And I had to, each pin has to have its own connection for it to be a true parallel circuit. Okay, so like if you link all the negatives via one connection to the power supply, that's a series circuit automatically. Changes the whole thing. So you got to do each negative individually into each switch, each positive individually into each switch. And then the base, which is this clip right here, each base gets its own connection too, which is hooked to the Hall effect sensor. The base is hooked to the Hall effect, which does the pulsing. Alright, so what I do now is I turn it up virtually all the way to 25 volts. And then I hit switch 1. We automatically get 1.3 amps. And switch 2. Switch 3. See the lights going on indicating it's an indicator light. So I'm going to see actually if we can get it to rev up at all with the 5 hooked up. So right now 5 switches are on, and let's see, 1, 2, 3, so 2, 4, and 5, no wait a minute, 2, 3, and 4 switches had no effect on the amperage. And then 5 increased it by 2.2 amps. And 6, when we turn that on, that connects everything else. And that automatically jumps to 2. And this will get whipping pretty good. I'm not exactly sure why 2 to 5. Or no, 2 to 4 switches don't have much impact on what's happening out here. I don't understand why each transistor doesn't have an equal impact. So if somebody could drop a comment or kind of help me out with that, why is that happening? And I've looked over all of the connections, they're all right. All I can think of is that something's loose in the breadboard. That's all I can think of.
Mike says nice work.
Thanks, Mike. Yeah, I had this virtually the same problem when I connected. I didn't have the black wires in here. I didn't have the negatives connected to the switches, and the lights didn't turn on. But you could still send power when you turn the switch on. So, I really don't know uh, what's up with these switches. And you can hear it kind of if you put it up real close. Hear that? And then those other ones are just like absolutely no effect. I don't understand why that is.
Mike does says you need to insulate the collector with mica.
Where you mean in the breadboard? Do I need to do that in the breadboard?
We'll see if you. I think you probably heard that. We'll talk to him.
Or on the transistor itself? Yeah.
But you can definitely follow up with him.
I personally don't know what there's two positive in and two negative out. I don't know what each one is for, considering that there's only, maybe it's to run the switches, maybe the switches need their own power source, I don't know. I think it's pretty not okay, it's like, I don't get it. Why there's two connections.
Alright. Mike does says if you touch the collector with your finger while it's on, it will begin to malfunction. Having mica insulator prevents you grounding the collector out to earth with your body or feet.
I get it, but is that like the oils in my body or something? Because I'm not. I mean, I'm insulated.
The
I'm wearing my shoes.
what are those things called? Ethelials. Yeah.
No, I mean I get that, but I don't.
You may not feel anything. Okay, that's what he said. You're touching it. So, HV crosses your shoes.
Okay. So are you telling me that those? Let me see here. 1, 2, 3 transistors are shot, and I gotta get new ones. Because if it can go way faster than this, man, we're hot. We're ready.
And then mica insulates HV. They will work and fool you. It happened many times to me.
So I don't have to get a new one? I got a whole box of them. I don't have to just switch it out?
It would seem, and then get the insulator. If you hear any noise in the trigger, the NPN is going bad, but it still functions. 50% function.
Okay, yeah, I've noticed some of the twitchiness of it once it feels like something in there pops, kind of. It like pops, and then it'll still function, but it's not as good.
Correct.
Yeah, I've had that happen. I'm surprised it hasn't happened with this Hall effect sensor yet, considering that I'm running at 25 volts all the time.
Twitching, unstable spin. Yeah, that's the result.
So hold on, let me test the heat here. Oh yeah, that's hot. We gotta turn this off. so we're just gonna turn it off for a minute, let it cool off. Yeah, wow, this is hot. Let's feel this one. It's hot too, just not as hot. Now this is what I do have available for the big coil here. I do have a 32 gauge strand that I wove through there. Excuse me. .32 and
Yep, there it is. And like we're videotaping it right now. It's okay. This is from Mike Does. It's okay to work with NPN uninsulated, but keep that in mind. All it takes is a finger to touch the collector when they are not insulated to create that malfunction.
and 38 gauge. That's good news, Mike. Thank you.
You should get 0.7 ohm from the collector to emitter versus, or vice versa.
Okay.
Same ohms as diode, 0.7 ohm or 0.5 ohm.
Man, working with all this hot glue has really become a problem. Well, it's always been an issue for me, but you know, I'm a hothead, very impatient. There we go. All right, so like if I wanted to do a trigger coil instead of Hall effect sensor, which I don't think it'll work better. I don't think so. It might, especially with 38. I have a potentiometer here. Now, I was just assuming, but I don't know for a fact, but doesn't that knob right there, the voltage knob and the potentiometer knob, look and maybe even do the same exact thing? It's just that this one doesn't have, this one doesn't click.
Interesting.
You can't turn this one off, you can just turn it all the way down. And I'm not saying that they're built the same way or they do the same thing. I'm just saying that this knob is probably the same thing. But yeah, I could put that on the trigger coil. It was another suggestion that I got. And that way I can control how much current's flowing through the...
Exactly. You said current limiting, variable resistor, POT.
pot.
Yeah.
Right on.
I like the conversation. This is cool.
Yeah, I was watching the Mermaid the other night. She was working with the DAX. I was like, oh man. Oh man. Yeah, so basically all those need to be insulated is what you're saying. Or maybe pitched out, thrown away. Because I heard that like once you bend the pin there, that it becomes, that somehow gets imprinted into the electrical imprint. From that point on, it's part of the whole thing. So it's good to keep the pin straight.
Mike Does says, after you find your potentiometer resistance setting, you can wind a coil to match that resistance and do away with the pot.
Do away with the what?
The POT.
Oh, the potentiometer. Gotcha. Well, this is what I did do. I did a coil with 1,555 turns of trigger and drive.
He just said pot is just to find the sweet spot.
Okay. So it worked out okay. With 1,555 turns. This has 666 turns, and it has 32 gauge and 38 gauge. So I could either run it on either one, or I could do a series circuit if it's not good enough.
Mike asks, what's the minimal voltage the 1.5 cable run on?
Minimum voltage, the 1.5K.
Yeah, the big coil. You remember that one? You were testing it the other day.
Oh, yeah. Well, since they're all hooked up to transistors, I'm thinking that the minimum voltage that it's going to run on is
The 1550 turn coil. My bad. That's the one I was asking about.
yeah, that was all hooked up to transistors as well.
Okay.
I'm thinking that the trigger coil would work. It's been so long since that. Well, not even that long, but.
Didn't you have one running at like 3 or like 1.8 the other day?
Yeah, but it wasn't hooked up to a transistor, I don't think.
Okay.
Definitely not a transistor. Because you got to have minimum voltage just to make it work, you know? Just so it'll turn on.
Well, we should start writing these numbers down.
Yeah, minimum voltage, I think, was anywhere between 5 and 7 volts.
That seems right, because we were there for a while. Yeah.
Yeah, anywhere between 5 and 7, it would kick on, the amps would just all of a sudden kick on.
Yeah, I think.
What I would do is I would position the coil to generate between 0.7 and 1 volts of DC electricity.
There it is. All right. I may have had my finger over the mic on that. Did you hear that? I'm still learning. I know.
See, so like this right here, this would be way too much voltage to run. What was I using? To do the transistor. That's way too much for the base. You only need 5 volts. But that's this coil right here.
Yep.
I guess what we could do is see. Okay, so this. Let's see how fast I can do this. And that's spinning for quite a bit of time, but I think that's inertia mainly, or 100%. It's a pretty heavy rotor, and it's oversized at 14 inches.
Okay, so he's saying, can you say what's the drive volts and the trigger volts for the 1550?
Drive volts.
So I think this one was the trigger. That's the drive.
Yeah.
And it's 4.5 and up for drive.
So I could trigger it with 1.2 volts on the trigger, and that was about 5 to 7 volts on the drive.
And we have more work to do because he says you can go as low as 0.5. So we will get there.
Oh yeah, I know. I mean, well, for the trigger, right?
For the trigger.
Okay.
I think he said between 5 and 7 for the drive. He's got it down to low as 4.2 on a drive.
All right, and then that
So he's got ceramic ferrite.
4 cores. Or for magnets on the rotor.
Magnets.
Oh, that's the wrong one. Okay, so that just blew my time schedule out the water.
He's got a Bedini style core.
I don't know what that is.
What's a Bedini style core?
Yeah, I don't know about anybody else's motors. I don't do my homework, basically. There's a gradient line, okay? And I like to fuck around to find out. The more you fuck around, the more you find out.
Ooh, copper coated iron welding rods for cores.
I understand. I get why you would get all that done. Iron in the center and copper to smooth the transition between the coil. Yeah. Well, that's what basically that's what I'm saying. It'll smooth everything out to have the copper coating.
Okay, he makes his own.
Really, Mike?
Shotgun pellets or BBs. Low carbon steel.
Yeah, no, I don't have a forge in my house.
You got a forge over there, man?
Yeah, I don't have none of that. This is actually a bedroom. This isn't a garage where I have a cement floor.
Yet.
Yeah, I don't have one yet. Yeah.
Yeah.
That'd be awesome. I'd love to do all this stuff on my own, man.
Oh, no, epoxy. That's my fault. That's the cameraman's fault. He was speaking of epoxy on that.
What are you talking about, bro?
Shotgun pellets in epoxy. I didn't even see that part down over here.
Oh, I got you. Gotcha.
So that's a lesson there. Okay. All right. So what are you trying here?
Right here, I'm trying
Wax paper. Indeed.
All right, so this is DC volts being generated by our 666 trigger coil strand. But of course, that's just normally we'd be able to just do it with our hands. So I'm thinking we're going to have to go series circuit with it, but let's start it up. I haven't hooked it up. I'm just seeing how much voltage being generated by the trigger strand in this coil. I think we need to move it a little bit closer. It's about 2 centimeters out right now. I think it needs to be about 5 millimeters away.
Okay. So like closer to that.
That kind of shocked me a little bit. Oh.
Do you have a preference with air cores?
A preference? I do like air cores better. I think that core coils is a whole nother mathematical ball of wax.
Okay, so I get that.
And that means a whole different distance from the rotor, different air gap, everything is different with core. You can't just put a core in and have it be. Not like this. This is hot glue. Okay? we're trying to make it work within our paradigm.
That's what I can see that.
And our paradigm is, we don't have big, huge acrylic chassis that, we could set up 8 rotors on. We don't have that.
Yes.
Yet. Might have somebody build us that stuff.
He said, LOL, true.
But we do have a freaking steel shaft and a freaking hole in the table. And we're making it work. And it's as rudimentary as it gets.
I think it's
I love it.
but at the rate that you're like advancing, I'm pretty sure you're gonna go there.
Okay, what was I doing? Oh yeah, I gotta move this down. Yeah, that coil's hot. Wow. It's just warm now. And then this coil seems to be a bit high compared to all the other coils, which means the rotor is definitely maybe it's just the angle. Yeah, dude. It's starting to sink in the middle.
Yeah.
Because of all this missing material here.
Right. So we'll have to set those up. Or
change the whole format.
Right, like we were discussing before. I think that might make for some interesting.
But I just, it's got to work, man, or I'm going to be really distraught. So we got to take it a step at a time. It doesn't have to work well. I don't care if it works well or not. I would love it if it works well, but that is not a requirement for me. All right, how far away is it?
It looks less than a centimeter.
All right, let's let that dry just a second. Let's make sure it's where it needs to be. See, I don't know about this one. That is where it needs to be. All right, let's give it a whack here. Well, bingo. That's the sweet spot right there. That'll work. And then once it starts catching, it'll continue to, stop dropping below the trigger amount and it'll stay where it needs to be.
All right, Mike says those Neos hold the gate down real strong and let a lot of current through. Make the duty cycle longer than it needs to. The faster you turn off the gate, the better. Can lower source volts or increase gap. So do you know all the terminology yet?
I don't know what's going on with that. I'd say this is pretty good. I mean,
He might have been typing that from something earlier.
okay. Yeah, I mean, I adjusted the air gap because the voltage wasn't high enough to trigger at all. It was between 0.2 and 0.1.
What are Neos? You have a strong trigger signal, maybe too strong.
Ah, isn't that what this is for?
Yeah, I think that's. Oh, the
Potentiometer.
Yeah.
Wow. But that's right. I hooked up the 38 and to fix this, no problem. I'll hook up the 32.
Can add resistance to the base with a resistor.
Here it is. Sometimes it's hard to see these things.
Yeah, I can't. I can't see it.
All right, so that it's about the same, roughly the same. I want to hook it up and see if it'll work, actually.
Flyback will kill the pot also, so a real resistor will maintain stability.
Okay. What type of ohms are we looking at? I got tons of different resistors, man. I got tons of them. I have no idea how to hook them up, though. Something tells me I put them in backwards or something. Can you put them in backwards? I don't even know. I just never had any luck putting a resistor anywhere in anything that I do. So,
What ohms is the pot reading now?
oh, it's not even hooked up now.
Oh, the pot's not hooked up.
Yeah, it's right here in my hand.
Mm.
Oh, what?
Use the resistance across the pot. Maybe 100 ohm.
Okay. So you mean parallel? That means parallel, right? When you say across. So running from here to here.
Do that again.
Running from this one to this one.
Before the base.
Now I'm trying to think, man, because the base is either it's the black strand on the Hall effect sensor, so it would be this is the DC coming out on this side, or the DC, yeah. So trying to figure out which one would be the base. It's going to be this one, right? This side.
And he said, limit your trigger signal with a resistor.
All right, so, all right. Now, in order to do this, I need to switch.
Limit the current.
No, the trigger isn't even hooked up to anything right now. So what I need to do is I need to hook it up to the base. So you're telling me I need to hook up 6 resistors?
Paige says, hi, Dad.
Hey, Paige. How's it doing, baby? So I need to hook up a resistor to each base connection on every transistor, right? Or do I just need to hook up one right here?
Paige says, I can't wait to see you tomorrow.
Can't wait to see you either, baby.
I think Mike's typing something long right now. or he's AFK. One of the two. Yeah.
I want to see because I got to hook this up. And I think that I got to hook up each.
Okay, here we go. If they are triggered together, then put the current limiting resistor at your signal generator output.
All right, so that would be the coil strand on see, this is going to be the grounded part, and then this is going to be connected to the bases. So I could just put it on this one let's see where this goes. Oh, we don't have it hooked up yet.
Between the output of your trigger signal and the basis.
So would it go before or after this diode right here that rectifies the electricity to DC? I think it goes after, right? Because as of this point, it's still one wire, still one. But once I disconnect the other end of all of those, these right here, and hook them up to this one,
Can go after or before, but after would be better.
all right. All right, so let me get these bad boys out of here. Let me see. All right, metal film fixed resistor, power 1/2 watt, resistance 1K ohms, tolerance plus minus 1%. Would these be good? Or are these too much? And is there a front or back to these things?
I would use a 0 to 1K ohm potentiometer to find the sweet spot. Then replace the pot with a resistor that matches the sweet spot resistance.
Yeah, I don't even know how to hook up that potentiometer to the trigger coil. So, yeah, I don't even know what to do with that. Because I don't have, in, so the power would go in, right? And then out would be connected to the positive and negative of the coil.
Put it in series.
This is trigger strand. There's 4 outlets to this thing, not 2.
With the trigger winding.
No, I understand. I get it. I just, there's only one connector. Yeah. I'm struggling to wrap my head around this. All right, so we got a right and a left side. Let's just look at it like that. You got a right side and a left side. Right here. Do both of these go to the in a positive and a negative? It looks like there's way too much stuff going on here for, an in and an out. If I was dealing with, the power supply, I can see you got a positive and a negative and a positive and a negative here. Huh. Maybe I made my trigger coil wrong. I don't know, because it feels to me like there's way too much going on with this. Oh, here we go.
Once you draw it out on paper, it'll make sense.
No, man. I'm sorry, bro, but those arrows didn't make any sense to me.
So he's been doing all this without any diagrams, man. This has all been in his head. And the way he draws the diagrams are wild.
So we got power. So that would be, is it power from the power supply or is it power from the trigger coil? Power from the trigger coil. All right. So the positive and the negative of the trigger coil go into the power of the potentiometer. And then the motor, it's all going to be plugged in to this. So
Yeah. Power from the trigger needs resistance.
I'm working on it.
Okay.
I'm working on it.
So it, like, yeah, I can see it coming soon because like the rate you're expanding, it's coming.
Power
Cause the
motor.
neos are sending strong, because the neos are sending a strong signal.
So the motor, which will be this, connected to this. All right, Mike, I got a question for you. Can I plug this diode directly in to the positive power terminal of this potentiometer? Can I just plug it in there like that and have it be clipped? This, of course, is the multimeter. You can just unclip that one and put it in here like this. Can I do this without burning my house down?
You can.
Sweet. All right, so I think that's what I'm going to do. You see that? Those questions like that is what stops me from doing some stuff sometimes. All right, so
You're good, bro. All right, I do need you to hold this for a second because I need to use my phone. Live TV.
all right. So our cameraman's taking a leak. That's awesome. All right, so the diode will go into the positive. The other end of the trigger coil will go into the negative of the power. And then we gotta see, because we got a mess right here. This is a trip. All those are hooked to the base of the Hall effect sensor. And I just got done connecting the emitter of all these transistors over here to the switchboard. And now the lights light up. The indicator lights light up. I think that's all it really did. Well, it individualized each strand because I had them all hooked up on the negative terminal with just one hookup, connected it to the power supply, and now they're all individually hooked up. All right. Yeah, I had them all connected together, and it seemed like it connected all the switches together when I did that. But I guess the ground doesn't really matter as much as the positive input. All right, that makes sense actually. I can put this back together the way it's supposed to be. Awesome. All right, bro's back. All right, I might actually have to do that to make this work. All right, so we're gonna do this real quick.
See if I can see them.
Plus minus.
You can isolate the collectors with HV diodes on their outputs. That's all right.
Here it is. Power plus.
That way any flyback won't burn out the other NPN. There we go.
Zoom in.
Yep. It was going back and forth for a minute. I'm learning. Let's see if I can pull that. Yeah.
I don't know. I should probably try and free up that wire just a little bit. Hopefully. Oh, it's wrapped. Rocking it back and forth seems to help.
Some of the action here.
Right.
I know that's really hard to see. Let's see if we can get.
Need to be like right there.
Okay, I will be positioned.
I don't think this strand is gonna work going in here. Or maybe if I like clip it to a bigger wire. I think I'm gonna need to because I can't see it.
You're close. You're right above it.
I'm also gonna do what I suggested.
Is that PWM?
What? I have a PWM, I have two. But this is not a PWM.
Okay.
This is simply a power distribution for a parallel circuit.
Is that your signal generator?
No, it's not a signal generator. I don't have a signal generator that's hooked up at all right now.
For the trigger?
I never used one, and I've made it work.
Interesting. So,
Never used one. I have no idea what the frequency of this thing is to begin with anyway, so it's not going to work. I mean, I've got it to spin really slow at like 0.0004 of a hertz.
Is that the power supply?
Yeah, that's the power supply over there.
This was the power supply.
Yeah.
Okay.
And then this one is the power distribution for each strand. So 1, 2, 3, 4, 5, 6. Simple. Power goes in, goes all the way around, comes out, same block right here. I thought it would be really cool just to see each strand in isolation.
Going like boom, boom, boom.
And then, yeah, add one together with the other one. And I got real disappointed because 2, 3, 4 don't do shit.
Yeah, you can watch the beginning of this live if you want to see that. Paige said, "You are my new messenger kids, PFP." I'm assuming that's a...
Oh man, what was I looking for? Yes, a bigger wire. Right, that we're gonna just use a diode. How about that? I mean, shit, we'll just have it pointed the other direction, right?
Yeah, I think
So
that was implied.
this one.
Oh, I see what you're saying.
That way, and this one will go this way, and we'll just hook the clip to the other end of the wire. Because I'm not gonna struggle with that 32 gauge trying to put it in this hole and then screw it in. Well, he's blocking the light. I'm just not, not gonna roll with that.
You don't want the collectors touching each other. Can use HV diode to isolate their outputs from feeding into each other. Not sure need see your diagram to know for sure. Got it. In general, 2 collector outputs can't touch.
Oh, they're not touching. They're all individualized. Thank you. I noticed that they're very. I've gone across all of this and made sure that they weren't touching. Now I will say that this thing vibrates a lot. So I go around and I check it every once in a while, make sure nothing is touching. Because I've noticed that when I'm working and I'll see cross wires, amps will go through the ceiling and stuff will start
Smoke.
blowing up, and we'll get smoke. And I'm like, God dang it. It's all because of this mess. It's all because of this mess, man. This stuff works. It just.
He's enjoying that.
We're not gonna start a fire, okay? We're not gonna do that. Although that would thrill me to no end. This is my house.
Oh yeah, you are. Yeah, you are, Pyro. I forgot about that.
All right, so, damn, that's really gonna bug me.
Here, I have a garbage can full of burnt transistors. Now you know, bro.
No doubt, man. People that like to get their hands dirty.
And here's half of them still work, but cause issues.
Yeah, I got my whole bag of stuff that's like 50-50.
Yeah.
I'm like, God damn, it costs so much money. I don't want to spend more money, but you got to get new ones too. You got to have new ones because when you try something out that's fresh, you got to have new ones because it's got to be fresh. And if it's 50-50, you don't want to put all that together and then well, what's not working right? You know, and then you got to find it. And it's like, oh man, what a drag. Bingo. Power in.
Got it. They last a while like that. Now I just, oh my bad. Now I just use heat sinks and mica insulation on my transistors. Okay, so we'll look into that.
Is mica like the insulation in computers?
You know, it's spelled M-I-C-A.
Yeah, yeah. It's like that insulation crap for computers, right? Circuitry.
Yeah, I'm pretty sure that. You're right.
All right.
They sell them for transistors. They're cheap. Okay.
Okay.
You get them in packs of 50. All right, so we just search for mica insulated transistor.
All right, man. What's next?
Yeah, so just search for that. All right, so you got.
Do I want to hook up all the negatives into one again? I'm not sure if I want to hook all the negatives up into a series again. I think I can, and I think I will. So
The transistors, the insulated transistors let the heat pass to the heat sink, but no volts.
and it's cool the way I set this up because 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, and 6 is 6 all the way around. So if it's 1, 2, 3, 4, 5, or 6 that's messing up on the switchboard, I know exactly which one is messing up. God, what do I do now? You want to hook the bases, which is all these, to the motor of this, the positive motor. Or is it the negative? No, it's positive because it's coming from this to this. No, it's coming from this to this. So
That's right.
this is going to be positive here. So I'll just get a new one.
POS energy flows to negative.
So POS.
Positive?
Positive flows to negative. Is that what he said?
I think so.
So
Yep. So like a river. And positive is higher elevation. I know that's a bad correlation. I know.
So I'm going to stick the positive end of this diode into the negative terminal.
Arrow on diode points at the negative.
Yep. Stripe positive points to the negative. That's good. All right.
Cool. Oops.
opposite direction.
And stripe side is the negative. Cool.
Stripe side is the negative.
Stripe side is the negative.
Then I got it backwards.
Okay.
Positive goes into negative. I always thought that the way that the electricity was flowing was the positive, but that's not right. The direction from which it's coming is the positive.
Right. So positive cannot pass through the stripe. Negative can. And I'm going verbatim from Mike. Where are you from, Mike? Positive flows the direction the arrow is point. Miami.
Okay.
We're in Detroit.
Oh yeah, Miami. And then that makes me wonder if I got these two right. Negative, positive. So it's supposed to go positive to negative, negative to positive. I think I have these all backwards. Like all of them backwards. Because it is supposed to be black to black, red to red.
Here, hold on. Take that
All right. So right now we got positive to negative all the way across the board. Is this backwards? That's all I gotta know. Two on the right are backwards.
I need a. Oh yeah, that's perfect. I need a stick I can hold.
Yeah.
He's looking it up. Flip all four around. You've got them all backwards. Yep, you were right.
All right. I'm gonna have to do those again. All right. That's good. I'm glad I caught that.
Your intuition was on.
Wish it was on when I was hooking them up, man. That would have been better.
Right. True. But it's rare.
When it's on and before hindsight.
Right. When you get it the first time when you don't know what you're doing.
What's going on with this?
And I shouldn't say it like that because you do know what you're doing. And you're getting better at it.
Yeah, I don't really.
You don't feel the same? It's like, I think I'm getting worse.
He is getting worse. Yeah, when I started out, man, oh my God, I was generating like 750 volts of AC electricity with 6 magnets. And it was made out of wood. And the shaft was it spun with the rotor. So the shaft was glued to the rotor, which was fine. It worked really good. Torque was amazing. But that's all on Facebook. Yep, that's all on Facebook, and I guess there's some rift between YouTube and Facebook because I can't
For sure there is.
get any.
And now X
Content.
and Google are joining in on that riff. Have you seen Anchorman? You know how like the crews meet up in the alley? That's what's happening right now.
Oh man, what a waste of time. This is exactly the time for that to be a waste of time.
Right out.
Because things are coming together so rapidly now that just standing in its way, you're gonna get your skin just melted off your flesh. Like
Mike said that's your signal generator for the base signal.
yes, the trigger coil will generate the signal for my base, which will trigger the transistor on. I'm not expecting a better outturn than using the Hall effect sensor though. I'm expecting it to be about the same, if a little worse. But we'll see. We'll see, because it's more, the Hall effect's off to the side, so it does like catch itself. But once it reaches this point right here, it's got a huge kick. It goes whoosh. And it's just like amazing. All right, now that we got that sorted out, mm, mm. All right.
Good job, man.
All right. So those are reversed and flipped, and I think it's all good now. Transistor, or the coil's hooked up. Now we gotta hook the transistors up. Yeah. Now I know what you're talking about. I'm like, this is gonna be tricky. But this is just for the base. Alright, so I was thinking that if we had to put the collectors on there too, that would be like impossible to do it this way.
I'm gonna try and zoom in. There we go.
Well, this doesn't seem right at all. So it's coming from this one or going to this one? Is it going?
Do that one more time.
Is it coming from the breadboard or going to the breadboard? The signal's going to the breadboard. So motor plus would be going to the breadboard, and that means this diode is wrong.
Let me zoom in on that.
Because it's going to only allow the electricity to go through like that. And I think it's got to go in right here. Like if I hooked them all on this side of the diode, I think it would work. But if I hook them on this side, it can't get through unless it goes in the negative, but I don't think it does. I think I had it right. Before. Yeah, I did. I did have it right before. All right, man. You can sit down if you need to.
Hard to see. Yeah. Like.
Yeah, the paint is worn off quite a bit of these.
Yeah.
So actually, I'm gonna have a seat, and I'm gonna redo these.
But you definitely have the indicators. You know what to look for now.
Yeah.
And you can see it in your mind. So I can't even do that. Yeah.
It's all right. It's better to get this right than to melt everything instantaneously. So we had it right. We did it. We had it right. It's okay. That's usually how it works, is we do it the best the first time we do it, and then all those times we're trying to make it better, we just make it right. Less is more.
Oops, that's fuzzy. There we go.
That's why I don't like, 3 pins and 4 ins and outs and all this stuff, because when it's just in and out, 1, 2, even if it's like parallel 1, 2, so 1, 2, 1, 2, 1, 2, 1, 2. They kind of melt my brain a little bit. Just smoke a lot of weed though, so might have something to do with it. All right, so negative.
Yeah, I gotta take a break here.
All right, so we might have to call it here pretty soon, as you heard.
It's a switching thing. That's right.
All right, so that, and then this next thing. Oh man, see this. Was of course the wrong thing. All right, power in. Power out. And immediately it transfers the AC to DC, and that's done already, so that's good. I don't know if this is gonna work, but we're gonna give it a shot. I bet some people are probably gonna be appalled by this, but I'm not really too worried about it. And just put right.
Oops.
It's messy. Messy. Now we just need a negative. Um, um, oh, that's right. All right, and then
Thanks, Mike.
yeah, thanks, man.
Have a good night.
You too, man.
We'll see you next time.
All right. Awesome. Thank you much.
All right. Did you want to give it a shot?
Yeah, let's give it a whirl here.
And then we'll end the live. And we can make a video if it doesn't work the way we want it. That was really cool.
Hell yeah, Mike. Thanks. Really appreciate it. I don't know where to set this at. Let's set it at 15.
All right.
Yeah, the amps are running.
Something is happening. Interesting. That is definitely got an attitude now. It's shaking.
All right, we let that go. All right, let's see.
Interesting.
Definitely not working the way I wanted to. It is working though.
And this is called the pod?
Pot.
Pot.
very much, people. Have a good night. Please subscribe. Bye now.